Welcome back to another CommCon Virtual 2020 session. This time we're with Dave Horton from the Drachtio project, and he's going to introduce us to an exciting new project of his that I'm really excited about, just generally. I'm going to pass you over now, and then I'm going to come back to you all afterwards, and we'll have a chat with Dave, and then we'll go to the Q&A later. So thank you very much, Dave, for taking the time. Over to you.
Well, thanks, Dan, and thanks everybody. I'm super excited to be here. CommCon is, a one-of-a-kind thing, especially when it's in person. And I have to say, I'm a little sad. I'm missing playing with the Falcons. I'm missing shooting crossbows. I'm missing shooting crossbows at the Falcons. But mostly I'm missing staying up too late, drinking with a lot of you ne'er-do-wells, coming up with brilliant ideas that we've all forgotten by the next morning. But hopefully next year we'll be able to be together in person and do that. In the meantime, since Dan is a show must go on kind of guy, he's decided to do something truly epic, and here we are, trying to live up to that. So I'm going to talk about a new open source project of my own called Jambonz. It's an open source CPaaS, communication platform as a service. So let me start by telling you the story of Jambonz. Many of you know me, if you know me at all, as the guy behind Drachtio, which is an open source platform and toolkit for building SIP server applications. And you can build many different types of applications with Drachtio. And I make as my business primarily doing consulting projects for customers. And that usually involves me building custom VoIP server applications for them. And so over the past year, I noticed that more customers were asking me to build applications that would let them migrate their services off of a commercial CPaaS, which I thought was interesting. And the reasons varied. For some, it was cost. For others, it was perceived call quality. And for others, it was new features that they needed and that they couldn't get. But regardless of the reason, I found myself building these kind of off-ramps for people that wanted to get off of a hosted CPaaS service. And so, as I was building a succession of these one-off custom applications, I realized a couple of things. The first was that if you had the right combination of tools, experience, and skills, building a relatively full-fledged CPaaS platform was actually not all that difficult, not all that big of a task. And the second thing that I realized, that there was probably a target market for this that would likely be fairly interested in an open source CPaaS you could host yourself on your own infrastructure, where you could easily plug in your own surrounding services like speech rec and SIP trunking. So at that point, I decided to launch another open source project alongside Drachtio to build a CPaaS, and that became Jambonz. Now, the title of my talk I call Jambonz the Little CPaaS. What do I mean by little? Well, I mean by little that Jambonz has a very modest vision and a very limited set of goals. There are other telco platforms out there that have very broad goals. These are typically UCaaS, Unified Communications as a Service platform, often based on a PBX, but then add in support for business logic and a large set of pre-built calling features. And then they often tack on support for webhooks as well to check the CPaaS box. And I think of these as kind of Uber platforms that really want to center themselves within an organization and be the hub within which all features exist. And that's fine. I have nothing against these platforms, though I think by their design, they require a large sort of buy-in from customers that deploy them, in the sense of having to kind of closely adapt your business logic to them. But Jambonz is not like that. By design, it is smaller. By design, it contains no business logic. It's really nothing more and wants to be nothing more than a simple, small telephony engine exposing webhooks and APIs. So how does it differ from other CPaaS services? Well, first, let's look at the way it doesn't differ from other CPaaS services. And that is, it provides webhooks and REST APIs. Same as the rest of the gang. No different, really. So nothing innovative there at all. Now, is that good or bad? Well, I think it's good, given that webhooks and APIs are so well understood by the customer base at this point in time. It does differ, however, in the following ways. First, and most obviously, it's that you can run on your own infrastructure, so you're not paying a third party to deliver it as a service. Second, you plug in your own services like speech rec, text-to-speech, SIP trunking, rather than paying marked up rates from a CPaaS provider. And third, of course, it's completely open source. The entire project's available on GitHub, and we'll take a look at it in a second. Now, there's going to be some customers that find those differences compelling and others that will not. There's really two intended audiences for this project: communication service providers and enterprises that have very stringent data privacy requirements. Service providers would be interested in Jambonz for two simple reasons: lower costs and the ability for greater network integration versus a commercial CPaaS service. And enterprises that have very strict data privacy requirements, such as HIPAA and PCI, may also be interested to the possibility or attracted to the possibility of running a CPaaS engine within their own protected infrastructure. Not have to worry about things like private data, such as credit card numbers or other customer identifiers appearing in a voicemail or a transcription that's housed somewhere on a third-party server and subject to being hacked. So these are really the two primary target segments for Jambonz. Now, let's take a quick look at the Jambonz architecture before I dive in and show you actually how the thing works. I use the following ingredients, if you will, when I bake this cake. So I'm using drachtio for all the call control and logic. I'm using RTP engine for the media proxy. I'm using FreeSwitch for some additional media handling. And I'm using MySQL for for storing provisioning data, and Redis for memory caching. Those are the ingredients. Functionally, a Jambonz deployment consists of two pieces: a session border controller and a feature server. So let's take a look at that. So the session border controller is responsible for session border type thingies, like setting the network edge, device registration, least cost routing, and so forth, and integration with your SIP trunking vendors in general. And the feature server is responsible for the CPaaS feature set that we all sort of know and love, and that's the main point of the application. The session border controller is built using drachtio and RTP engine, as I mentioned, and the feature server is built using drachtio and FreeSwitch. Part of the FreeSwitch install includes some plugin modules that I've authored for integration with AWS and Google, and these are available on their own as open source on GitHub as well. This is a picture of what a production deployment looks like. The initial deployment is AWS based, so I've done a lot of work to make this very easy for someone to spin up a Jambonz deployment, a Jambonz cluster on AWS. And we'll look at that in a bit. But when you look at a full production deployment, you would have a couple of SBCs spanning a couple of availability zones. The SIP signaling and the RTP media would be split on different servers. And then you have feature servers living in an autoscale group that can expand or contract as needed based on load on the system. And then, as I mentioned, we're using Redis and we're using MySQL. So I've created making it easy to use a serverless MySQL database. And we are also using, when on AWS, we're using simple notification service for some of the cluster events, the autoscale events. And connected to that would be your SIP trunking vendors, and you would use your AWS account and your Google account for speech access to speech. So that's what a production deployment would look like. A sort of smaller deployment for testing or for small deployments could be as small as one SBC and one feature. Everything else kind of the same. Okay, well, what I want to do now is a couple things. First, I'm going to build a cluster from scratch to show you how easy it is to do. And then we're going to use it and build some applications and kind of get you familiar with the feature set. Let's see, what do I want to do? Okay, I'm going to jump over here. So I'm sharing my screen now, and you can see on GitHub where the project lives. And all of the repositories are under here. It's all open source, MIT license. And you'll find a link here as well to a docs page, which we can open up in a new tab, which will give you documentation about the project and specifically about how to interact with the project. One of the projects here is called Jambonz infrastructure. This is a set of Packer scripts and Terraform scripts to let you build AMIs and then to sort of blow out a complete Jambonz deployment, a BPC and everything you need in it. Take a quick look at it. We're going to run it in a second. So it's got both Packer and Terraform scripts. It's got information here that tells you what you need to do to run it. If we look at the Terraform scripts, we see, as I mentioned before, you've got kind of a dev test type of deployment or a prod deployment. Let's look at the dev test deployment. You don't need a lot of familiarity with Terraform to be able to just to run this, but it is helpful. There's a couple of prerequisites and they're described here. You need to have both AWS credentials and Google credentials because we use Google for speech recognition and optionally for text-to-speech. We use AWS for text-to-speech and we use a bunch of AWS features like SNS and so forth. So you want to have an account on both GCP and AWS. With AWS, you then take your access key and your secret access key and you would put it into this variables.tf file, which is sort of a bunch of configuration choices on where you want to build this, this cluster that you'd be deploying. With GCP, you download from GCP a JSON key and you would put it in this credentials folder, which is empty right now in the checked-in version, but you would put it in there as a file called gcp.json, and that's described down here. Once you have done that, then you're able to actually run. So let's actually go look, and I'm going to spin up a cluster here. So I'm in the dev test. I'm going to spin up a dev test cluster using Terraform. So I just go terraform.apply, and it comes back and in a second confirms what it's going to build for me. So you may be able to see here, it's said it's got 24 different artifacts it's going to build. So that's everything from a VPC to a couple of EC2 instances to an autoscale cluster to security groups to an Aurora database, Redis, etc. Pretty much everything soup to nuts you need in its own VPC on Amazon in whatever region you want. I'm going to build this one in the US West 1 region, I think, which is California. So it's going to go ahead and do that. I'm going to come back to that later. What I want to do now is switch to another cluster I've built and show you Jambonz in action. Let me switch back to my browser. Now, so Jambonz is a CPaaS, and if you look through the documentation, it's going to be mostly pretty familiar to you because you're going to see all of this, the typical verbs that you're used to. Dial, say, gather, hang up, conference, queues, all that stuff is here, and it's all documented on this page, which is right off of the GitHub, linked from the GitHub repo. You can see we're using JSON format instead of XML, but if you're familiar at all with CPaaS and with the concept of webhooks, it's very simple. You're sending webhooks and you're returning a payload, which is an application describing what to do next. Now you can build your application with whatever application server you want. However, to make it easy for myself, I did build some Node-RED nodes, and I'm going to do some examples in Node-RED. I've already got my Node-RED server running, and so I've got all of my Jambonz nodes here. If you want to add them yourself, what you do is go to Manage Palette, you can click Install, you can search for Jambonz, and you'll find it, and you can install it from there. Everything is going to start with a webhook. We got a webhook coming in and eventually a webhook going out. Pretty much that's what's going to happen. And you can see there's some documentation with each of these. When we, on the webhook in, we get a message.call payload, which will have all the details of the call. And then you use these other nodes to create an application and return it with the webhook out. It's pretty straightforward. We'll look at that in a second. I should back up briefly. For those who aren't familiar with Node-RED, it's a low-code programming environment. I think there's a great talk by Sam as part of this, so possibly you've already seen that and you'll have some familiarity with what it is. If not, it's as I mentioned, it's kind of a graphical drag and drop editor used a lot for Internet of Things types of applications. And it can be used for quite a bit of things. So I've added nodes for Jambonz. One of the things that Jambonz can do, besides handling calls coming in and then routing them and doing stuff with them, it allows devices to register as well. And when it comes to device registration, the authentication of the device is actually delegated to your application. So it's not like some CPaaSs where go into the CPaaS and create SIP credentials. There are no SIP credentials held by Jambonz. Instead, when a device tries to register, you get a webhook call and you get a chance to authenticate it or not. Let's actually just go through that as an example. So to do that, we're going to use this user auth node. And in the user auth, we're going to be given in the webhook everything that came in the authorization header, everything that the device provided to authenticate itself, including the username, the SIP domain, and the hashed response. And it's up to the application then to use that username and domain, retrieve a password, and then provide the password into this node so it can be authenticated. And you can provide either a password or a hashed password. So for my case, what I'm going to do, let's just have a simple in-memory database. I'm going to link these up. So I'm going to have a webhook. Let's say it's going to be a post. Just going to say auth. So I'm just going to create a simple in-memory database. Nothing fancy. Typically, you'd have obviously your database of users somewhere else. But let's just have a simple object that's users keyed by a SIP domain, and under there we have user passwords. And so then we will want to look up the domain. Now, in the case of an authentication request, excuse me, we have a message property called auth request. So it'll be message auth request, which has all of the details of what's being sent to us. If I switch over here and we click in the documentation on authenticating SIP clients, you can see we're basically going to get this. We're going to get a payload that has everything that came in the authorization header. So it'll have a username, it'll have a realm, and all that, and it will have a response. But all we want to do, all we want to do is look at the, let's say, if users, look for that domain. If we have it, then we'll say, actually, we'll set a flow variable. So we'll say flow.set. Password to users message auth request. Actually, I'm going to save myself a little typing. Okay, so we're really just taking the realm. We're looking up to see in our little database if we have that. If we do, we're then looking for the username key, and we're taking the value of that and setting it as a password. All that is really just setting a flow variable as the password. And let's just say, call that lookup password. all of that is just to let us here stick this variable in here and let this user auth node determine whether or not it's matching. And then we return it back. And to give a sense of what we're seeing, let's just log out some of this information that's coming in. So we'll just say, let's have a look at what we're getting in message.auth request. And we'll have a look at what we're sending back in message.auth response. Okay. So now we've got an application that's ready to handle registrations, but let's go. My cluster needs to be configured to point to this application. So there's a provisioning GUI, a pretty simple provisioning GUI that comes with Jambonz. And so this is looking at this cluster, my test cluster. I've got one account. I can create others, but we'll stick with one. And if I edit the account, I can specify things like the SIP realm, which in this case will be jambonz.us. I can specify an application that should be triggered when devices make outbound calls. I'm not going to do that right now. And I can specify a webhook to be called with registration. And I can choose either get or post. So I'm going to choose post. I'm going to save that, I think. So now I've got an account with a realm. Devices can register against that realm. When they register, it's going to call this callback, which should, yes, match up to here. Okay, so let me bring up my Bria phone. And I've already got those credentials plugged in here. So Dave H with the domain. I'm going to go ahead and try to register. Okay, and my phone successfully registers, as you can see. Now, if we look here, what got logged out, we can see in the auth request, we're getting that information that I talked about. So we're getting a payload with everything that came in the register, and it's up to us to send a response back. That's all handled by the webhook out in the user auth, but we sent back a status. Okay, that's why the device got registered. So now I've got devices that can register against my account. Let's go ahead and do a simple application to test things. Let's just have a simple application that says something and then makes an outbound call. So we'll use a say. Well, actually, we got to start again with the webhook in. And we'll do a say. We'll do a dial. And we'll do a webhook out, which we can just use the one we already have. This is going to be an outbound call from my device. Let's just call it SIP trunking. So it's a post to SIP trunking. And we'll do, so say, welcome to CommCon. Please hold while we connect your call. And this is going to use whatever speech I provided as default when I created the application. We'll look at that in a second, but we can change it to anything we want. Again, we can use Google or AWS. So if I wanted to change it to Google, I'd have a choice of all the Google languages and so forth. But let's just go back to leave it at application default. And then we're going to do a dial. In this case, we're going to dial to a phone. And in the message object, we're going to get a payload with this, with the incoming call. It's going to be in this call object, and one of the properties is going to be the actual dialed number. So we're just going to dial out to that number. So we'll simply do that. Now let's log some of this out as well so you can see a bit about what's going on. Let's just log message.call. And we deploy that. So I've got an app that'll be triggered by SIP trunking, but I haven't set that up. So I'll go back here and let's create an application. I don't have an application. Go ahead and do that. Let's just call it SIP trunking. Associate it with the default account. The web URL is going to be http://app.jambonz.us/SIP trunking. And I'll do it again with a post. Oh, and a different webhook for call status. So let's just call that call status. And here for the application, again, we have a choice of what we want to set as the default. English UK and okay, so we've added an application and there's the webhook. Let's go back here. We have a call status event we need to handle as well. So let's just do that. Not going to do anything with the call status. So that should be good. So now my phone, which is registered, I should be able to, theoretically, I should be able to place calls with it. Oops. Hold on 1 second. Let me see what I did wrong here. Oh. What I did, I forgot to associate the application with my account for when devices make calls. So when registered devices make calls for an account, it'll trigger this application. For incoming calls from DIDs, we can associate it with phone numbers, which I'll do in a sec. Okay, so now we should be set to make our call. I'm going to call my cell phone.
Welcome to CommCon. Please hold while we connect your call.
Plays the prompt and that connects the call. Hello, hello. One of the things I've noticed in that is that the call was connected as soon as it hit this save verb. But we may not want that because billing will start when the call's connected. So if we want, we can play the prompt over early media. We'll just come up here and say we want to play that over early media. And similarly in the dial, we don't want to answer the call until the far end answers. So we can click answer on bridge and do that. And go ahead and save and deploy that. Just to give you a quick sense of how that works. Okay, one of the things you might have noticed in that scenario is that the call was answered as soon as it hit the platform. Sometimes we don't want to do that. Sometimes we want to play a message over an early media connection, and we can do that. Just to show you how we go in here, and we can select early media. And similarly, when we dial, if we don't want to propagate answer until the call is answered, we can say answer on bridge. So let's just make those two changes and deploy. Do a quick test, and you'll see this time, if you can see the screen, you'll see it's in a ringing state right up until my phone actually answers.
Welcome to CommCon. Please hold while we connect your call.
Hello, hello. Hello, hello. Okay, so that is outbound calling. Now I want to show another feature, which is Microsoft Teams integration. If we go back to the accounts here, and we go, or to the GUI, and we go to settings, we can enable Microsoft Teams integration. I've got an SVC domain name on Microsoft Teams of teams.jambonz.us. So I'm going to save that. And then we can have tenants under that team. And I'm going to create a tenant called davh.teams, and I'm going to associate it with that default account. Again, I can choose any application. I'm just going to choose the same SIP trunking application. So now if I go into Webex Teams, once again, I can excuse me, make the same call. Let's see where's. Okay, I'm totally forgetting where in Teams this is. Sorry about this. I'm trying to remember. Let's bring this back up, I guess. Oh, sorry. Anyways, if I go back into Teams and I want to make an outbound PSTN call, I'll dial the same.
Welcome to CommCon. Please hold while we connect your call.
Hello. Let's just look at one other thing we can do on the dial command. Oh, before we leave that, I did want to show you the information that we get on a webhook. So this is for these webhook calls. We get the typical kind of information you're probably used to in the CPaaS: caller name, the number that was dialed. We, in addition, get the full SIP object. So if you needed something out of any of the headers, that's actually there as well. One last thing we can do in the dial command, actually there's a bunch, but just to show, if we want, we can have a live audio connection and fork the audio and send it to a WebSocket server. So let me just say, let me create a little URL for that. Let's just call it audio. And I've actually implemented a node that can act as a WebSocket server. We're going to say audio, and we can just upload that audio into an S3 bucket. I've got a bucket, I think it's called Jambonz recordings. Let's go have a quick look. Yes, Jambonz recordings. I think it's empty right now. So let's just have the audio of this call saved off to S3. And we'll make the call one more time.
Welcome to CommCon. Please hold while we connect your call.
Hello, hello. Okay. Make the call. If we go back to S3 and we look at recordings, oops. We can see we've now got a file in here. It's a recording of the call in linear 16 format. I'm not going to download it right now, but it does come with a bunch of metadata attached to it that shows the call ID, the unique call identifier, and so forth and so on. So a simple way to create voicemail or call recording feature from there. Back here, I want to show a couple things in the GUI as well. So we have the ability to have SIP trunks. So I have one SIP trunk set up from a company called 382Com, and I've got phone numbers from them. And so then with each phone number, when calls come in on a phone number, I could choose an application to associate with that. Probably wouldn't want to use the SIP trunking, but I'd create another application if I wanted to. So that's the typical kind of routing amongst phone numbers. That's kind of a brief, quick overview of Jambonz and how it works. Another thing I wanted to show you was some monitoring and alerting integration. Here's a dashboard built in Datadog for a live system running Jambonz with calls going through it. And you can see it's easy to integrate for monitoring and alerting. We can see the number of calls going through the SVC, inbound, outbound, number of calls on the feature server. See the load averages, which are pretty low, call stats. We can see webhook response times here, which are nice and low. This is at the average, close to the 50 milliseconds with a few spikes on the 95th percentile. We can see the round trip Google TTS times, which are about 200 milliseconds on average. Another thing we do, which is useful, is TTS. So not hit the TTS, we can cache it if the same voice and same text is used. Here you can see a chart showing the percent of TTS requests served from the cache. It's about 95% served from the cache, so it's great at keeping the cost low as far as using your AWS or Google accounts. Okay, that was the basics of what I wanted to show you on Jambonz. Switching back to a few last slides. I want to talk a little bit about the roadmap. So what's coming up in the future, what I'm looking to add. Messaging support, so right now it's voice only, but I'll be adding messaging shortly. Second, Google Dialogflow integration, so you can connect a call to a Google Dialogflow bot. Thirdly, you can see there's already some monitoring and alerting integration with Datadog, which is a great hosted service, but I want to integrate as well with some of the open source Homer, Prometheus, Grafana set as well. This has all been AWS based, so we'll be doing a GCP based Terraform deployment. Down the road, I put a question mark next to it, but it would be nice to have a Camelio based SVC option, so possibly we'd be looking at that down the road. And that's it. I want to thank you for coming along on this brief journey with me. If you feel free to ping me if you need help getting started, you want to try this out, or you want help building it, that would be awesome too. If you're looking for some SIP trunking in the US, I would check out 382Com, who I was using in this demo. Got some contact info for you there. They have probably the best rates in the US and great service as well. In any case, that's it. I really appreciate the time and look forward to answering any questions that people might have.
Thanks a lot, Dave.
All right. Thank you.
A lot of people know that I'm a huge fan of Drachtio. I'm not a SIP expert by any means. I know enough to get me going and to get me by, and then I know enough smart people for me to go and ask questions to. And I'm not like, so Camelio for me, for example, is way too kind of low level, whereas Drachtio gives me this huge control in a programming language that I like. So Jambonz kind of looks like this other step for someone to be able to get going very, very quickly and have something running within their own infrastructure. So really, really interesting project. I should just chuck you a ton of money every single year, because every single project you come out with is really, really interesting and useful to a lot of people. We're going to move over to Riot now, riot.commcon.xyz. The link will be in the description below, where Dave will be available for Q&A. I think that'll be a really, really interesting session, so make sure you go over to Riot, and we'll all chat there shortly. Thanks again, Dave. It's been really, really insightful, and I'll see you all soon. Cheers. Don't go anywhere quite yet, though. We've got to say thank you to all of our sponsors. Without them, none of this would have even happened in the first place. So for our platinum sponsors, we've got Toulouse, Voxbone, and Ciara. For our gold sponsors, we've got the Matrix Foundation, Vonage, Sangoma, Telviva, and Loway. Our silver sponsors are Aptosay, Pion, Telco Bridges with ProSBC, Avoxy, 8x8 with Jitsi, and FirstCom Europe. And we've also got community sponsors, QXIP and Cycor Systems. Without any of them, this would never have even happened. You wouldn't have had all of this free content on YouTube. So go say thank you to all of them. Go look at what they provide, what services they offer, and have a conversation with them all over on Riot, riot.commcon.xyz. The link will be in the description below, along with links to all of our sponsors. You can go and watch preview videos from all of our gold sponsors right now over on YouTube. The links will be somewhere over here. All I've got to say is thank you to all of our sponsors, and I'll see you over on the Q&A shortly. Cheers.